Why are we even doing the POC? Is it just to validate an idea? It's very easy to do a proof of concept with AI. But when you want to take it to production, it comes with a lot of the challenges. And I think during the POC, you may do a lot of manual things, but when you actually want to scale it to production, you need to make sure that you automate a lot of those processes so that you have a very effective data interface.
So what are the common technological and infrastructural challenges AI developers face during this scaling process?
Having some principles in terms of where you need to invest on the infrastructure will simplify a lot when you actually start looking at productizing the solution. The models continue to evolve. We have seen this so frequently, with GPT coming in.
How do AI developers navigate the challenges of maintaining data privacy, ensuring model security?
The difference is more in terms of the sheer volume of data which you have to consider. Bringing that data lineage is going to be extremely key.
Hi, welcome to the AIM Leaders Council podcast. Today we have Swaroop Shivaram. Swaroop Shivaram is the Senior Director of Data Science at Lowe, where he leads initiatives of ML and generative AI platforms and products. With a rich background spanning nearly 2 decades, Swaroop specializes in computer vision, NLP, AI, and ML technologies. His career includes pivotal roles at Lowe, where he led the computer vision technology for operations. Hi Swaroop, welcome to the AIM Leaders Council podcast. How are you today?
Doing good, Purvi. Thanks a lot for being.
I hope it was not a lot of traffic while coming to the office here.
For a change, I think it was a breeze today, not much of traffic, so I'm just on time. So
we are all happy to have you here. So let me ask you the first question. When transitioning from POCs to enterprise-wide AI implementations, developers often face significant challenges, including the need to scale data pipelines, handle larger volumes of diverse data, and ensure data consistency. So how do AI developers overcome these challenges, and what strategies or technologies are most effective in ensuring robust data management at scale?
I think from an AI proof of concept to production, there are a lot of challenges when we want to get into the production, right? And being an AI practitioner for quite a while, one thing I've noticed is it's very easy to do a proof of concept with AI. But when you want to take it to production, it comes with a lot of the challenges. So I always look at when I'm doing an proof of concept, setting up a clear objective of the POC itself. Like, why are we even doing this POC? Is it more to validate the business value and the business use case, or is it more to validate the tech feasibility, or it's a combination of both? I think that's going to be extremely key to define what you're going to do as part of a proof of concept. Now, once you know what is the objective of the proof of concept, it's also important to set the expectation of the proof of concept. So today, with all happening on AI, generative AI, there's so much of excitement. Every business leader is looking forward for how do we get AI adopted, right? So keeping that in mind, there is excitement, but at the same time, when we have such an high excitement, then there is also we need to have a clear expectation of what is the outcome of the proof of concept itself, right? So clearly defining the proof of concept expectation is going to be key. For example, if I'm a retailer and I'm building an prediction model for predicting the inventory of a product in the store, my proof of concept might just start with 1 or 2 store pilot, where I get the data from 1 or 2 store data and then basically go ahead and build a model and then test it out. Now, we want to scale that from 1 or 2 stores to, let's say the retailer has thousands of stores. There's a lot of work which goes into it. And I think setting out that clear expectation will make sure that you're level setting with the business team that this is where we're getting, right? So that's more towards setting the expectation. After that, I think it's all about the foundational things, right? When you're building the AI model, obviously, how do you make sure that your data pipelines are robust enough, where you get data from various different data sources, and how do you automate a lot of those processes so that you can train the model more frequently and then in a more effective way. So I think the data pipeline, automating it is going to be one of the key foundational things we need to do. And once you have the data, then it's all about cleaning the data, making sure that your data is curated well enough. And I think during the POC, you may do a lot of manual things, but when you actually want to scale it to production, you need to make sure that you automate a lot of those processes so that you have a very effective data in place. And then the last one, when the critical part is also more about the MLOps itself, and making sure that you have a robust MLOps pipeline to train the model, deploy the model, and also post deployment, how do you effectively monitor the model? I think these are the key foundational aspects you need to consider while moving from an POC to a production, so that you'll be well prepared to do it.
As AI models move from controlled POC environments to dynamic real world applications, issues such as model drift, scalability, and the need for continuous retraining become difficult. What are the specific struggles AI developers encounter during this transition? And how do they ensure that these models remain accurate, relevant, and efficient across different operational contexts?
Yeah, I mean, I think when you're doing a proof of concept, you're doing it in a very controlled environment, where you've taken a subset of the data which is used for training the model, and also your outcomes of the model. You know what is the ground truth. So basically, you have a way to measure what is the accuracy of the model when you are doing it in an experimentation phase. But once you actually take it to a production, it's very hard to know what is the accuracy of the model, because there is no real feedback coming out from it. So that's one of the challenge where we use some of the proxy metrics to address it. This could be more like indirect way to know how your model is doing, right? So one example is, if you built an AI solution and you're asking the user to give a thumbs up, thumbs down. So that's one way to get a feedback. But again, that requires somebody to give an feedback, which not necessarily that everybody would be willing to provide, right? So there are, in some cases, you have to look for ways how you could get that information without having any human intervention. For example, if I'm using AI solution to count the number of people in a building. Now you can always look at a proxy metrics where the number of people who are coming to the building and the number of people coming out of the building at the end of the day when the building closes is what is the error we have. Like number of people who entered versus the number of people exited the building should be same. So now this could be a metrics which you kind of use it to measure how well the model is doing in the production. So first ground rule is to establish what would be the proxy metrics or the metrics you will use to measure the accuracy of the model in production. Once you're done with that, then it becomes more in terms of monitoring the solution so that your accuracy is not deviating from what you anticipated for. So this could require more proactive measures to know how the model is performing in the production. Is there any deviation which we are seeing? If there is a deviation, can we get an alerting mechanism so that you get an alert and then go back and analyze and then see what could have caused the deviation in the accuracy? This could be a model drift itself. It could be a data drift itself. So if it's more of a data drift where the data has changed over a period of time, then you can actually update your data pipelines to make sure that you rebuild the model to get your accuracy back. If it's a model drift, then maybe you may look at what could have happened with the model. Can you fine tune the model, or you're going to look at for a different model? I think that's more of an action you should take out of it. So having a way to defining or agreeing on a metrics which when you get into the production deployment, and also post that a proactive mechanism to monitoring and taking necessary action is one of the way to make sure that you avoid the model drift and other things. There are a lot of other tools which could be leveraged as well, but I think these are the grounding principle in terms of monitoring and then taking taking the necessary actions around that.
Deploying AI models at an enterprise scale involves overcoming hurdles related to infrastructure, such as ensuring sufficient computational power, optimizing model performance, and managing latency in real time applications. So, what are the common technological and infrastructural challenges AI developers face during this scaling process, and how do they mitigate these issues to maintain high performance standards?
Yeah, I mean, I think definitely the infrastructure plays such a big part while building an AI solution, right? So when you're doing a proof of concept, it is also good to figure out what would be the infrastructure investment you're going to make, so that it gives an heads up in terms of where the investment is going to happen and also what is the return on investment on top of it, right? So as part of it, one way to look at is where exactly you need to do an investment of the infrastructure. Is it on the cloud or is it on the edge computing? So it all depends upon number of factors when you are making this decision. For example, if you are looking at an AI solution where you have to make real-time decisions, and then if your volume of data is so huge, then it makes more sense to deploy your AI models very closer to where the data source is getting generated. The second scenario could be more, you need a real-time response, but your volume of data is very less. So in that case, maybe a cloud-based solution could be a better way to look at also. The other possibility could be more, these AI solution need not be real-time. In those cases, maybe investing more on the cloud or a data center makes more sense from an investment point of view. I think having some principles in terms of where you need to invest on the infrastructure will simplify a lot when you actually start looking at productizing the solution. The other aspect also to look at is, can we do a trade-off on the accuracy? Because not necessarily that all the models what you build needs to be extremely accurate, because the use case might demand, okay, with 1 or 2% less accuracy be taken care of, right? In those cases, doing a trade-off of the accuracy versus infrastructure could also one way to look at how do we scale it. And the models continue to evolve. I mean, and we have seen this so frequently, like, with GPT coming in with 3.0 and then 4.5, now the mini version of GPT is still giving you the better performance. So I think the core is more about how well you can optimize the models, so that, over a period of time you would have invested it, but at the same time you continue to optimize your models so that it can run better on the low compute infrastructure. So there are a lot of tools and techniques how you could actually optimize it, both from an hardware infrastructure point of view and then more in terms of fine tuning the model. I think some of those are the techniques to look at while looking at scaling the AI solution, at the same time utilizing the infrastructure in a very optimal way.
Ensuring the security and compliance of AI solutions during enterprise wide deployment introduces complexities, particularly in regulated industries. How do AI developers navigate the challenges of maintaining data privacy, ensuring model security, and adhering to industry specific regulations while scaling AI solutions?
No, I think security and data privacy are such an important factor when we're building an AI solutions, right? From a security point of view, a lot of the things which we have seen in typical software development are pretty much similar for AI as well. Just in AI, the difference is more in terms of the sheer volume of data which you have to consider, and also a lot of the data which we use in AI, most of the cases it is unstructured data. So that brings its own challenges and complexity in terms of how do you make sure that, the security is taken care as building a part of the AI solution, right? The way I look at this is more, we need to look at this holistically, right? Right from the way you collect the data, they store the data, and they train the model. How can we make sure that the security and then the data privacy is embedded as part of the entire process? So in terms of data storage, if I talk about, how do we make sure that right control and accesses are provided to the users who have access to that data? Then also bringing in, if I'm having any personal information about an user, a customer, and how do you make sure that you're encrypting it and all those. So those are some of the key practices you need to follow as part of the data collection and curation process itself. Now, when it comes down to the training the model, obviously you don't want to train models on any of the personal information and other things. So making sure that you do various approaches, like there are a lot of various approaches in terms of data anomalization is one, where you could actually mask out the data and use it for training the purpose, right? And you can also generate a lot of synthetic data to actually create those model training thing. But again, too much of data anomalization also doesn't help, because then that point of time the model train may not be that effective. So some of these definitely as part of the data collection, curation, and model training, you can take care as part of the data security and then the privacy, right? And then the other aspect is also to look at how do we bring in more data governance or AI governance, in terms of making sure that if we have a very good governance in place, right from where the data came in, what is the source of the data, who modified the data source. So bringing that data lineage is going to be extremely key when you are building solutions at scale, right? And also making sure that can we detect the bias which is there within your data set, because it's going to be extremely important when it comes down to the scaling as well as training the model, right? You don't want to introduce bias in your data set. So there are a lot of tools again to make sure that you check those data bias if it's already there, to address it while you are training those models, right? Then the second part is then the other part is also about the being ethical when you're building AI solutions. So a lot of the times it ends up more like the technology is there, let's just go ahead and build it, rather than really do you want to build it, in terms of validating that business value itself or the reason to build it. I think that's more we need to look at when we are building these models, and also making sure that everybody understand why we are doing, and also being more responsible when building those AI solution is going to be key as part of any AI solution development, right from the proof of concept to the productionization. If you take care of some of these aspects, definitely both from a data security, data privacy, and from an being a responsible AI development, I think could be taken care of.
So, the journey from POC to enterprise wide AI implementation often requires adopting new tools, frameworks, and methodologies to address the limitations of initial prototypes. What technologies, shift, and innovations are essential for AI developers to successfully scale their solutions, and how do these changes impact the overall AI development lifecycle?
Yeah, I think there are a lot of tools and frameworks which are coming every day, and all of these tools and frameworks are basically focused towards improving the efficiency of how you deliver an AI solution. So when I look at AI solution, there are two aspects. I always call it as operational metrics. One is focused more towards how effective is your solution, which all talks about how good is your AI model, what is your accuracy and other thing, right? The other one is about the operational efficiency. So how good is your process in building the AI solution? How efficient is your process to build an AI model? I think that's where a lot of these tools and frameworks comes into picture. And then the focus is more in terms of identifying what are the opportunities you have where you can improve the efficiency of the solution what you are building. So often what happens is when you're building a proof of concept, there are few manual steps you take and then move forward. But when you actually want to start scaling into a production, how do you automate some of those manual steps so that you can be more efficient in the whole journey of building an AI solution, right? So that's where the focus shift more towards identifying the opportunity. And then this is where also the innovation comes in. It need not be always on the product features, but also in terms of the innovation also could be identifying those opportunities itself from an efficiency point of view, right? So once you have those efficiencies identified, the opportunities identified, you will also go back and look at how do you make sure that this gets embedded into my product backlog. This could go as a tech dev where you could actually work on these opportunities so that you can be more proactive in terms of automating a lot of these processes so that the entire AI development cycle becomes more efficient. Yeah, I think that's what I would say more in terms of identifying the opportunities, and then go ahead and use the right tools and frameworks to automate some of those things so that the overall process is more efficient while building the AI solution.
That was very insightful, Swaroop. And I'm sure without a lot of innovations in the AI platforms, it is definitely going to make a lot of difference to the new generation that's coming in. We do thank you for coming and making some time for us. It was lovely having you here. Thank you so much.
Thanks, Purvi. Thanks for having me here and enjoyed the conversation. Thank you.